Good afternoon, everybody. Today, we're going to talk about dungeons, which is problem number 2 of day 2 IOI 2021. The online charge, again, is on oj.uz. The problem is like this. You have n dungeons. In each of the dungeons, you have a dragon. It's your opponent. Your opponent have a strength of SI. So you are the hero. You can go into a dungeon, let's say it's called X. If your strength is more than the opponent, the dragon in the dungeon, then you win. And your strength increased by the dragon's strength, and then you go to another dungeon, which is determined by WI. The strength of the dragon itself doesn't change. Okay, still SI. If your strength is less, then you lose. If you lose, your strength increased by another different number, PI, and then you go to a location of LI. Okay, and it says the game ends when the hero enters the last dungeon end. And the problem statement is defined in such a way that you will be able to get there, regardless of your starting strength and the starting location. Okay, the question is, if I ask you Q times, what is, and your starting location and the starting strength, and you want to find out the strength when you reach dragon end. The limitation is here. You have 4E5 locations, and you have 5E4 queries. So obviously, from here, each query has to be done in log n, right? So you need overall complexity of n log n, or actually n log n squared, and you will find out later. So each query has to be done in log n, basically. The problem is like, if you think about it, the problem is like this. If I initially here, and my dragon have a strength of this, maybe I will go to this location, and then I'll do a comparison. Maybe I lose. I'll go there. Then I do a comparison. Maybe I win. I will go here and I go back and forth until I get to the last dungeon, right? So we know we can easily do O(n) squared. That's easy, right? Because you can just trace down the path. The question is how I don't trace down the path if I do an initial calculation, but I don't trace down the path. How do I find that? Let's ignore the strength part first. Okay, let's simplify the problem. Let's say every time you will win. Okay, let's say your initial strength. Let's say your initial strength is infinity. Okay, look at the special case. Let's say initial strength is infinity, so you will always win. Then you will go to WI, right? You will go to WI. How do I do that in log n? That is a standard binary jump problem, right? So if you, again, go if we go to the ucycle.guide by Benjamin Chi, in the Platon level, there was binary jump. We previously used this to find LCA, right? Because you want to remember originally what we did. The reason we did that was if you have a tree, right? Where is your least common ancestor, right? So let's say from X and Y, right? We trace it up, but we don't want to trace up one by one because that's so we can do trace up binary jump, right? 2 to the power of 0 is 1, 2 to the power of 1, and 2 to the power of 2, and so on and so forth, right? So if you can't remember what that is, I just remember, right? You can do, for each point, we will find where is the ancestor in 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 2, so on and so forth, right? So then I will see if I want to jump up 5, then I say, oh, 5 is less than 8, but it's more than 4, so I jump up by 4 first, then I jump up by 1, right? Then I convert step by step up by log n, right? So that's our binary jump. So coming back to this problem, let's say then for each point, right? For each point, each dungeon, I can find, if I go one step, 2 to the power of 0, if I go 2 step, 2 to the power of 1, if I go 4 step, 2 to the power of 2, I mean, this is all if I just go by one side, right? What will be the location I will end up with? So let's say here is 2 to the power of 3, okay? So for example, if I want to find, this is, if I did this initial case, then from here, if I want to step up by 7 steps, okay? So then we know 7 is bigger than 4, less than 8. So I jump to 4 here, right? I jump to here first. I can directly jump from here to here because I already pre-calculated. Then I have 3 steps left. Then from here, then I jump 2 to the power of 1, right? 2 steps because 3 is more than 2, less than 4. Then here I jump 1 step, right? So I basically did a log n jump. Then I can find it. So now I know, so if my initial condition is infinite, strength is infinite, then I can do an initial calculation. Then for each search, then I easily can do log n. So now let's think about a little bit more complicated. Z is not initial, right? So what can I do? I can do 2 binary jumps, right? So I will have initial n locations. Then I have an uplift of location, right, which is this. Then I also need to know, if I know my strengths, okay, if at each location I know my strengths, okay, iterate through all strengths, then I can easily do this, right? It's basically the same thing. But that is n, this is n. So I take this strength, I use the same binary lift, binary jump. Okay. Right. So I basically bracket my strengths. by another thing, right? So I can binary my strengths same as this, right? Yeah. In this case, just follow the solution I'll show you. I will use base 8. Okay, you can use any other base. You can use base 3, base 5, base 6, whatever, right? Because it all tend to log n. Just for the fun of it, I'll use base 8. Okay. So then I break. So I calculate. I'll do it. For each location, I'll find the situation. If your uplift is 2 to the power of something, and if your strength is base of 8, log 8 to the power of something, right? So I can do all those jump, but one thing has to be careful, right? I can go from here to here because initially in this case, my strength is infinite, right? If my strength is not infinite, how do I know I can directly jump from here to here? What if, sometimes it's win, sometimes it's lose? So for each case, I need to set a boundary. Let's say strength limit. Okay, so I'll set the limit. So if my, for example, from here to here, right? I go there because I win, is because my strength there is bigger than the dragon's strength, right? So let's set the limit for each location, right? For each uplift of the location, and for each binary uplift of the strengths, right? So such that if I want to win, I need to have that strength, at least that strength, right? So if I want to go here, I need to be able to have my strength is bigger than any of those, right? The maximum of any of those. So again, that is another equivalent of DP, right? Basically, you have two DP. You have a DP of uplift, and then you have a DP of the limit. So then you can comfortably, then if you want to do this uplift to here, you say, oh, is my strength is bigger than that limit? Yeah, if my strength is bigger than that limit, yeah, I can definitely go there. If my strength is, let me set the lower limit, okay? If my strength is smaller than the limit, then I'm not going to go over there. I have to look at, maybe a step down here. So then that you're done. So you have a binary search uplift of this location and the binary uplift of the strength. Then you basically solve this problem for each query. You solve this problem in n log n squared. Okay. The example code is this one, example solution. For you to easily understood it, I took this and I made some comment, which is like this, right? So we have n locations. Each of them, I want to have the location. Sorry, I wrote it in this case, I wrote it in the reverse order, but it's the same thing. I want to have the location uplift, and I want to have the strength uplift. The location is 4E5, right? So if I take log 2, which is like 20, so you can do anything more than 20. So let's say, for example, 21 or 25. The strength, the maximum strength is 1E7, right? As it says here. If you have add up more than 1E7, you will always win, right? So you don't have to consider anything more than 1E7. So 1E7, if you take a log 8, that is 8. So the maximum is 9. Okay. Then every time, I have my how much gain I'm going to get, and I will have the limit, and I will have my where I'm going. Okay. So you do an initialization. So for the initialization, you first, right, for each location, you first consider 0, next step, 0 left. I mean, 2 to the power of 0 left, right? So in this case, let's set the base strength, right? The base strength is 2, this term, right? Is 8 to the power of 0, 1, 2, 3, 4, and so on and so forth. So if the base strength is bigger than the strength of the dragon there, then you win, right? Then you go to the next location, which is wing of I, right? You gain this much, and your limit is infinite, right? Of course, if you went to N, then you can just mark yourself, say, oh, I'm winning already. I don't need to go further. Okay. I mean, if you lose, then you go to the last lose location, right? And you gain P of I, and your limit is the S of I, right? Because you lose means you have to be less than that, less or equal that. Okay. So if you set up the first step, then you can do it for every next step, right? For every next step, you do the uplift, right? So, I mean, if you already win, then you don't do anything. Otherwise, right, you basically do the standard uplift, right? You go to the from your previous step, right? You go step log, you go the location power -1, right? For that strength. Okay. So, and the same for the gain, same for the limit. Right. Once you did the initialization, then the query is very simple, right? So for your initial location and your initial strength, right, so then you basically find where is my my strength that satisfy that limit, right? Satisfy that base to the power, right? Then you're going to go uplift, right? Then you go uplift, and your strength will gain that much. Of course, this is under the condition that you have not reached the end, and you are not reaching the limit, right? Upper limit, right? You're staying within the upper limit. Remember, if you're staying within the upper limit, you can jump. If you exceed the upper limit, you should not jump, right? So you do the uplift, then you, after you finish the uplift, then you say, hey, where am I going, right? So if I'm bigger than that, then I can go to, go to next step is go there. If I'm smaller than that, then I go to the loose location. So then after all this done, then you return your strength, right? So that's pretty, I don't want to say straightforward. It's two-dimensional binary jump, right? It's two-dimensional binary jump. But the concept is the same concept as we used when we calculate LCA, okay? The example code is here, and I will publish it. the link at the end of the this class. Okay, so I know for a lot of you guys, this is the final week. So if you still have a final next week, please prepare for your final. For those you don't have final anymore, good luck, right? Hopefully you already done with your AP class finals. Next week, we're going to talk about register, which is the last problem for IOI 2021. If you have finals, just don't worry about it. And the next weekend, you can finish the Dragon and the registered problem. Okay, and next week is our last week of this year's class, and after that, hopefully you have a good summer, and I'll see you next week.